Hi again. Welcome back to Module 4, Economic Valuation of the Impacts of Climate Change in Agriculture and Natural Resource Management. We're down to our last lecture, which is on time value of money, discounting, and net present value. In a way, this lecture can be considered an annex. What it will do is basically to help us understand the need for discounting and why we always read about net present value whenever projects are evaluated. For this lecture, we will be doing some computations, so please have a calculator ready. Let's start with the time value of money. The time value of money is the basis of most profitability indicators. It considers the effect of time on investment decisions. The time value of money recognizes that the values received earlier are worth more than the values received later. The time value of money changes through time for several reasons, and the first is consumption. There is normal preference for present over future consumption. Second is investment, because the money invested today can earn interest or generate income in the future. Third, we have risk and uncertainty, and we know that chances that something will go wrong increase with time. In general, we can say therefore that the value of money decreases through time. Now, how do we incorporate the time dimension of money in decision making? We can do this using discounting and compounding. First, let us define discounting. Discounting means bringing a future value to its present value using an interest rate. On the other hand, compounding means bringing a present value to its future value, again using an interest rate. Both discounting and compounding allow the comparison of amounts of money that are paid or received at different points in time. Let's look at the discounting formula. Here, we see that VO, or the present value, is equal to VN, the future value, divided by 1 plus I, the interest rate, raised to the power n, where n is the number of years in the interest-bearing period. This discounting formula is the one that we usually use to get the present value of a future amount. Let's look at an example. Let's say you want to have $5,000 5 years from now, and the interest rate is 5% per year. How much should you deposit in the bank today? The problem gives us the following information. $5,000 is the future value, or the amount that we would like to have in the future. The number of years is 5 years, and the interest rate is 5% per year. In this case, we are looking for the present value, or the amount that must be deposited today. That's our VO. Our solution would look like this. We start with the formula, VO is equal to VN over 1 plus I to the n. And substituting, we have $5,000 divided by 1.05 raised to the fifth. Please compute the answer now. The answer is $3,917.63. I hope we got the same answer. But if not, you can try to compute the answer again later. For now, let's proceed to net present value. Net present value, or NPV, is the difference, or net, between the present value of benefits and the present value of costs. This is the formula for NPV. Does it look Greek? It does because of this symbol, sigma, which simply means summation. If we are going to dissect the formula, we can see that the numerator tells us that we have to subtract the cost for each year from the benefit for each year, after which we divide by 1 plus I to the t. Doing so will allow us to get the present value. We do the same for all benefits and costs by year, and after we have obtained the present value for each year, we just sum them up, and what we get is the net present value. How do we use NPV to assess the financial or economic feasibility of projects? If we get an NPV that is positive, it means that the project is feasible. This implies that the present value of benefits exceeds the present value of costs. On the other hand, an NPV that's negative implies that the project is not feasible because the present value of benefits is less than the present value of costs. If the NPV is zero at the given interest rate, it means that the project is as good as the next best alternative because the present value of benefits equals the present value of costs. That ends the lecture on time value of money, discounting, and net present value. This also ends Module 4 on the economic valuation of the impacts of climate change in agriculture and natural resource management. The next lecture will be by Rizaldi, who will be talking about managing risks in agriculture and natural resource management due to climate variability. Before I go, let me assure you that I do not really expect everybody to become economists after this lecture. The main idea of including a module on the economic valuation of climate change impacts is just to develop an appreciation for the economic dimension of climate change. Bye!